So we're going to now look at how to sketch cubics, and the main thing is that we need to factorise the cubics. That's going to be the big job, or they'll already be factorised maybe, but they must be factorised. And then we're just going to join the dots. That's the method we're going to do. Excuse me. So the dots that we're going to make are going to be the x-intercepts and the y-intercepts, and then we're just going to use the fact that a cubic has got this shape and join up the dots. So for x-intercepts we know we put y as naught, for y-intercepts we know we put x as naught. So we've got three factors for the cubic here. The first factor is x, and then x minus 2 and 2x plus 1. So we're going to put y equals 0 to find the x-intercepts. So we're going to be looking at this equation. X, 0 equals x minus 2, 2x plus 1. That's the equation that we want to solve. Yep. So first thing, do you want to break it apart into its three separate factors and to put each one equal to naught individually?
Okay, so we've got x is 0.
That's one possibility.
X minus 2 is 0.
That's a possibility.
And 2x plus 1 is 0.
Exactly. They're the three possibilities to make the product equal 0.
Yeah.
So each of those should give you a separate value of x.
Well, this one's obvious.
Yep.
X is 0.
Yep.
Here x is 2.
Yep.
And in here x is minus a half.
Yep. Great.
What?
So we've got our x-intercepts.
At 2, 0 and minus a half.
Yeah. Brilliant. So do you want to put those on as dots? Again, do you remember from the, I think we've already done some other sketching, you don't have to measure it out, but roughly they need to be in the right position. That's it. Yeah. So you wouldn't have the minus a half equally distant from 0 as the 2. The 2's further away. Okay, so we've got 3 dots already. We usually find a fourth dot, which is the one on the y-axis. And to find the y-intercept, we'll do the opposite. We put x is naught. So we're going to take the original equation and put x is 0.
We've got 0,
Yeah.
and then 0 minus 2,
Yeah.
and then 2 times 0 is 0, 0 plus 1.
Yeah. So we're doing 0 times minus 2 times 1, which is 0, So in this case, we end up just in the same place as we've already got the dot. We've got the y-intercept there.
Yeah.
And then all we need to do now is join it up.
Well, we know it's a positive x.
Yeah, so it's not this shape, that's a negative cubic. It's the positive cubic shape. So it goes up through there, down through there, and up through there. Beautiful. And it's turning halfway between each of the roots. Lovely. Okay, let's try another one. Same thing. For the x-intercepts, we're going to put y as naught. So we've got
0 equals x minus 2 squared x plus 1.
break it up into its three separate factors, because there's 3 factors there.
Right, well, I know I've got 0 equals x plus 1 there.
Yep.
And then the squared tells me that I've got that bracket twice.
Yes.
So x minus 2 and x
Yeah.
minus 2.
All cubics are made up of 3 factors.
Yeah.
In this case, 2 of the factors are the same, but there's still 3.
Yeah.
So this should give you 3 roots.
So x is 2,
Yeah.
x is 2 again,
Yeah.
and x is minus 1.
Yeah. That's it.
So 2, 2 minus 1.
Yeah. And we call this a repeated root. Repeated because it obviously it is repeated.
Yeah.
So it's the same root twice. So what happens when we put these on the what's it called? What? Graph. That's the word.
Yeah. Well, let's put the points in. Okay.
Axes. That's the word I was thinking.
So we know it's positive, so we know it's going
Yeah.
to fit.
So this is a negative cubic, and this is a positive cubic, and it's going to be a positive cubic shape.
And it's got a repeated root here, so it's going to look a bit like an x squared, isn't it? Where it kind of just kisses the.
Yeah. It's going. What it's going to do, because obviously you might think, well, let's go up through here and then down through here, but then you've got no more roots.
Yeah.
So you can't come back up again, just because that would create a root that wasn't there. So what you're going to do basically with this repeated root is it's almost like with the first one we're going down through the 2, down this way, but then with the second, the repeated root, we're coming back up also through 2. So it's almost like we're coming back up through 2 and down through 2. And what that creates is like you said, almost like a quadratic at this point.
Yeah.
A turning
It's going
point at
down
that
and
point.
upwards.
Down and up through 2. So whereas the 1 is a single root, it sort of slices through, single root slice through. So it's slicing through there, but at the double root, it just touches and goes back up again. So it goes both down and up through the root, so you end up like that. Exactly, yeah. What about the y-intercept? So we put x is 0.
With y, and then we've got 0 minus 2 squared, so plus 1.
Yep.
So that is minus 2 squared times 1,
Yep.
which is 4.
Excellent. So we can label that one as well. Perfect. There we go. Nice sketch of a cubic. Okay, this is just to sort of show you that you can go in the opposite direction, back up from the graph to the equation almost. So we've got a double root here. You can tell it's a double root because it's just sitting on the x-axis, and oops, throw the pen away. And a single root here. So we've got a single root, that's where it just slices through. And we've got a double root, that's where it just touches the x-axis.
Yeah.
So that means our x-intercepts are minus 2, 3 and 3.
Okay.
So we must have been solving x, well we must have got x is 3 twice
Yeah.
and x is minus 2.
Yeah.
Which means we must have been solving x plus 2 is 0, x minus 3 is 0 and x minus 3 is 0. So what we must have been doing originally in order to find the x-intercepts is to put y as 0 and have 3 factors, x plus 2, x minus 3, and x minus 3 again. So you can work either from the factors down to the roots or from the roots back up to the factors really to get the equation. And once we've got the equation, obviously we can find the y-intercept.
Yeah, well, our equation is must be y equals x plus 2, x minus 3.
Yep.
So we just pop in x is 0.
Yep. Y-intercept, x is 0, x-intercept, y is 0.
Minus 0 plus 2, and then 0 minus 3 squared,
Yep.
which is 2 times minus 3 squared. That's 9, that's 2. It's 18.
Yeah.
That's 1.
Yep. So the y-intercept is 18. Exactly. Perfect. Okay. In your pack, you've got a little activity to do. Find out where these things cross the x-axis and the y-axis. So pause the video now. See if you can find out what the y-intercept and x-intercepts are, and then unpause the video, and we'll go through the answers. Okay, we'll go through the answers now. So the first one isn't actually a cubic, it's a quadratic. It's only got 2 factors. So the y-intercept, this is the x minus 2, 3x plus 1, crosses the y-axis when x is 0. So we get y equals 0 minus 2, 0 plus 1, which is minus 2 times 1, which is minus 2. And it crosses the x-axis when y is 0. So when y is 0, we get 0 equals x minus 2 times 3x plus 1. So either this factor is 0, that would give x is 2, or this factor is 0, which would give x is minus a third. So that's a quadratic. It would look a bit like this. It would cross the x-axis at minus a third and 2. 2 is a lot further away than minus a third. And it's a positive quadratic. And so it's going to look like this, turning halfway between the roots, and the y-intercept is minus 2. Okay, I'll rub this off and then we'll have some room for the second one. Okay, next one.
So the next one is a cubic, 3 different roots. So crosses the y-axis when x is 0. So we've got minus 1, that is a minus, isn't it? Yep.
Yeah.
1 and minus 2. Well, minus times a minus is plus, 1 times 1 times 2 is 2. And then it crosses the x-axis where y is 0. So we've got 0 is x minus 1, x plus 1, x minus 2. So either x minus 1 is 0, so x is 1, x plus 1 is 0, is minus 1, or x minus 2 is 0, so x is 2. So we know we've got point at 1, point at 2, and point at minus 1. There are no repeated roots, so all of them are going to be slicing through, and it's a positive quadratic cubic?
Yeah,
Yeah, it is,
positive.
isn't it? Yeah. So it's going to look a little bit like that.
Yep.
Ish. And that point there is 2.
Yeah. The only criticism I would make of that graph is that the turning points are always halfway between the roots, and because we've got 1 and minus 1, the middle is 0, so the turning point would, in this case, literally lie on the actual axis, which it doesn't usually, but it's only because minus 1 and 1 are the same distance apart. Perfect. Okay, let's see if we can create some room for the next one. So, final one, we've got another cubic. So, if we put x is 0 first of all, we get y equals 0 plus 3 squared and 0 plus 1, which would be 3 squared times 1, which is 9. And then when we put y as 0 to get the x-intercepts, we've got x plus 3 squared 2x plus 1. So either this factors...
And that equals 0.
Oh, equals 0, good point, didn't put y as 0. So either this factor is 0, which would give 2x plus 1 is 0, so x is minus a half, or this one is 0, which is x plus 3 is 0, x is minus 3. But because we've got that squared there, this is actually twice. So we've got x is minus 3 twice, that's important. Okay, so if we come to sketch it, well, we know that we've got a positive cubic, so we know the shape. We've got a single root at minus a half, that's a single root, that one,
Yeah.
and a double root at minus 3.
Yeah.
Yes, minus 3, which would be over here somewhere. And that one's a double root, the minus 3. And then, so the graph is going to come up, sorry about drawing over myself, the graph is going to come up and just touch at minus 3, not slice, because it's a double root, then turn, then slice through here. So we're slicing through that single root, and we're just touching at the double. Just a touch there. And then that makes sense with our y-intercept, which we worked out was 9. Hopefully you got all those right. Right, so this on the second page is just a way of clarifying for your notes, really, what's going on with the shape of the cubic. These are all positive cubics. So this is one example of a positive cubic. Slicing through once, slicing through again, and slicing through again. So 3 roots, 1 here, 1 here, 1 here, all single. So this cubic would look something like that, where they're all different numbers. If this was, I don't know, I can't work it out, but anyway, numbers. Number, 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 and they're the roots going along there, 3 singles. We could also have a cubic which slices through and then just touches. So we've got a single root here, and then a double root here, and that double root would give 2 brackets the same, which would obviously we would indicate with a square. Yeah. There's also the possibility, if we move that graph up a little bit, that we would slice through and then turn, but the turn is too high to cross through the x-axis. So you end up with one single root. If that's a, that would be x minus a. But then, obviously, we need a quadratic to make a cubic, exactly. Otherwise, we don't have a cubic. So we'd have some sort of quadratic in here. But when we tried to solve that quadratic, we wouldn't find it had any solution. So it would be a quadratic with no roots. So that is another possibility, that it only actually crosses once. So it can cross once, it can cross twice, it can, well, cross once, touch once, or it can cross 3 times. That's the possibilities for a cubic. But either way, in order to sketch it, we need it to be factorised so that we can see what the roots are, and then put the dots on, join the dots. Okay. There we go, that's the page I was looking for. Okay, so you've got this exercise to have a go at. It's basically leading you towards sketching all these quadratics. So you're going to first of all think about the roots, and then we're going to move forward and sketch them. So pause the video, just go through and work out which ones have got a double root, which ones have got a root at x is 1, which ones have got a y-intercept of -6. Just think about it and put ticks in if you think it's got that feature. and then we'll go through the answers. Right, let's have a look through, see which ones have got which features.
Okay, well I'm going to do double roots first, and I know that if I've got a double root, I'm going to be looking for something like that, with another bracket or something in there,
Yeah,
aren't I?
yeah,
So I'm looking for anything that has a squared
yeah,
bracket. So this one
Yeah.
here has one, this one here,
Yeah.
and this one here.
perfect, perfect. What about a root at x is 1?
Well, a root of x is 1 means that I'm looking for bracket x minus 1,
Exactly.
because I want to solve that and get x equals 1.
Yeah,
So I am looking for that, which means that this one has got 1,
yeah,
this one has got 1, this one has got 1, that one's got 2 of them, lucky it, and that one's got 1.
yeah. And in fact, this one's a single root at x is 1.
Mhm.
This one, like you said, is a double root, so that would just be just a little touch like that at the point 1. This one's got a single, so that would slice through
Yeah.
at 1. It would just go chunk like that, same as this one would just go through. This one has got a single root at 1, and this one's actually got a triple root at 1. If we have a look at this one just for a sec, what we've got here is basically x minus 1, x minus 1, x minus 1. So at the point 1, we're going up through the graph, and then simultaneously back down through the graph, and then simultaneously back up through the graph, which is a bit weird, but what it ends up looking like is it's going up, 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 and then all in one go it slices up through, down through, and back up through. And then what you end up with is what's called a point of inflection. But probably a better way to think about this is from what we've done previously, our work with transformations. We know that y equals x cubed looks like this.
Yeah.
So, I'll just move that down out of the way. So y equals x minus 1 cubed, that's an inside transformation, so it's going to move it right, it's going to come up, let's just move right 1. So it's probably a easier way of thinking about it. Okay, y-intercepts.
Well, let's take this off. We're probably going to need the space just for, aren't we? Okay, so it crosses the y-axis when x equals 0. So I'm going to need to substitute x equals 0 into all of these, aren't I? So y in the first one then is minus 0 minus 2, 0 minus 3. And because of that one there, I know it's just 0.
Yep,
Yep.
0.
The second one got 0 minus 1 cubed, which is minus 1 cubed, which is minus 1. So that's not minus
Yes.
6.
I would, actually, this is true. 0 minus 1 cubed is minus 1 cubed with brackets round, which you're right is minus 1 times minus 1 times minus 1. And then the 3 minuses make a minus.
Yeah.
So it's minus, and then 1 times 1 times 1, which is 1 cubed, which is minus 1.
Yeah.
It's just you have to be really careful when you write, and this is a really, really common mistake that students make, is that they write minus 2 squared, and they mean minus 2 squared. And minus 2 squared doesn't equal minus 2 squared. Obviously, it does the way I said it. But minus 2 squared isn't the same as minus 2 squared. So you have to be really careful with use of brackets.
So it's just being lazy.
Yeah.
Right. Okay, so third one then. 0, 6, and minus 1, which is 0.
Yes, not minus 6. Wonder how many people fell for that one.
Then the next one is minus 6. 0 plus 1 squared, that's just 1 squared,
Yep.
which is minus 6.
Yay!
That's that one
Yep.
there, isn't it? Next one then, 0 is minus 2, 0 plus 1, 0 plus 3, which is minus 2 times 1 times, and I'm being lazy with the times, is minus 6.
Yep, minus 6.
Oh, this is very glorious.
Yeah, minus 9, yeah. It's always a good idea to you know, be careful with those squares. A lot of students would forget it and think that was minus 3.
Mm-hmm.
3, rather. Yeah.
Minus 1 squared 6, which is minus 1 squared is 1.
Yes, exactly.
6, yeah, which is 6.
Yeah.
So that's not 1.
Not 1, no, exactly.
And then 0 times 6 times minus 1, which is 0.
Yeah.
Just
Yeah,
those two.
always important to remember the squares, and also if you're timesing by 0, it's 0. No.
Yeah.
Exactly. So just those two. So really, this is just an exercise in picking up the details of how you sketch, and then what we're going to do is go through and join the dots to sketch them. So pause the video, have a go yourself, and then I'm very quickly going to go through them and show you what they would look like sketched. Okay, so this first one, we've got x-intercepts at 0, 2 and 3, 0, 2 and 3. We've got a negative cubic, so that's actually this shape, 0, 2, 3. This second one below, we've already discussed, I would think of this as a transformation right 1 unit of a normal cubic graph. To find out the y-intercept, we put x is 0, minus 1 cubed is minus 1, so that's going to be minus 1. Next one, we've got 6, and then we've got minus 1, and that's a repeated root minus 1. So we know that we're slicing through 6, and we're just touching at minus 1. It's a positive cubic, so it comes up, touches, turns, and then goes like this. To find the y-intercept, we put x is 0, so we get minus 6 times 1 squared, which is minus 6. So that's minus 6 there. Okay, here we've got minus 3, but that's a double root, so we've got that twice, so it would just be a touch, and 1. So here's your 1, here's your minus 3. We're going to come up, it's a positive cubic, so we just touch there, and turn, and then slice through the 1. My turning point isn't in a very good place, sorry, because it should be halfway between the minus 3 and the 1, and it isn't. Then to get the y-intercept, we put x is 0, so we get 3 squared times minus 1, which is minus 9. So this is minus 9 here. Okay, this isn't factorised yet, this one in the top right. I wonder if you noticed that. There was an unfactorised bit, and it always needs to be factorised, fully factorised, so that we can work out what our roots are. So we've got 1, we've got minus 1, we've got minus 6. 1, minus 1, minus 6. We've got a positive cubic, so we're just slicing there, slicing there, slicing there. To find the y-intercept, we put x is 0, so that would give us minus 1 times 6, which is minus 6. So the y-intercept is minus 6. Okay, hopefully these are getting a bit clearer, what we're doing. So we've got x-intercept 0, minus 6 and 1. Minus 6, 0 and 1. Positive cubic, so up like this, down and up, and obviously we already can see that the y-intercept is 0. A couple more to go. We've got 2, minus 1, minus 3. So minus 1 here, minus 3 here, 2 roughly there. Positive cubic, so slicing through, slicing through, slicing through. And y-intercept when x is 0, so we do minus 2 times 1 times 3, which is minus 6. So there's minus 6. And last one, we've got 1 twice and minus 6. So we've got double root at 1, single root at minus 6. So we're going to slice through the minus 6, turn, and just touch the 1, and then go off, positive cubic. And y-intercept when x is 0, minus 1 squared times 6 would be 1 times 6, which is 6. Done.